Hello, everyone. Good evening, student. Welcome to today's physics class, 12th physics. Yeah, okay, right. Today, we are going to dive into the world of capacitors, specifically looking at how they behave when we combine them, okay, and how they store energy, right? So understanding capacitor is not for only for a classroom. Okay, it's not just for classroom. It has a real world applications that save lives. For example, I will share the screen now. You can see one picture. Okay, once again. So, so understanding capacitor is not just for a classroom. It has real world application that save lives. For example, the invention of the defibrillator by William Hoven relied on the principle of using capacitors to store and release a large amount of energy to restart a. Okay, so this knowledge has saved countless lives. So this is very inspiration to us. Yeah. So right. So this is for this is the importance of capacitors. Okay, right. So capacitor is a device which is used to store energy, store charge. Already you know about that. Yeah. Okay. Before we get started, let's quick three question quiz to refresh our memory on some key concept from our earlier classes, previous classes. Okay, right. I will share the screen and also you can see the question paper pre quiz. Okay, all right. So this is the uh, first question. This is the first question. Already my volume, speaker volume is 100%. Okay. This is the first question. What is the unit of capacitance? What is the unit of capacitance? What is the unit of capacitance? Ohm, farad, volt, ampere. Which one is correct? 2. Okay, good. GGBB, GJG, Rala, 2. Okay. Yes. 2, Kavida. Yes. Very good. Good. Farad. Yes. Correct. Very good. Second one, in a capacitor, where is the electric field strongest? In a capacitor, where is the electric field strongest? Which place? Yes. Okay. 2. Then, okay. Okay. Okay, good. So in a capacitor, where is the electric field strongest? Between the plates. Very good. Great. Very good. And the final one, important formula. What is the formula for capacitance of a parallel plate capacitor? What is the formula for capacitance of a parallel plate capacitor? 1, 1, 1. Good. 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 Okay. Super. Good. 1. Yes. Correct. Right. Very good. Okay. We can check the answer. Here we go. What is the unit of capacitance? Farad. In a capacitor, where is the electric field strongest between the plates? And what is the formula for capacitance of a parallel plate capacitor? C is equal to epsilon A by D. Yeah. A is the area of the plate. D is the separation between the plates. And epsilon is the permittivity of the that space. Yeah. Okay. Right. Good. Right. So before entering into the class, only one small announcement. Okay. We will be conducting evolution test. Okay. From 10 September 2025 to 12 9 September 2025. Okay. So classes 11, 12 mathematics and class 11 physics respect date. Okay. And from 18th September to 20th September, classes 12 physics and classes 11 and 12 chemistry MCQ test. Okay. The test will be in the MCQ format. There will be 25 questions. Okay. 25 questions. Each question will be displayed on the screen for 1 minute. Students must write their answers on a white sheet. Duration 30 minutes, approximately 30 minutes. Okay. After the test, papers will be exchanged. Okay. Papers will be exchanged and peer correction will be done during the discussion. A Vidyasakti champion will be announced in each grade. Okay. So please prepare well by revising all the topics covered so far. Okay. So topics, all the topics covered so far. Correct? Okay. All the best. So now let's go into our core concepts for today. Okay. Any doubts? Okay. No doubt. Okay. Good. Okay. Right. First of all, already we know about the capacitor. Already I told that. So now capacitor combinations. That is, when we connect multiple capacitors, we can combine them in two main ways, like series and parallel. Okay, series and parallel. In series connection, capacitors are connected end to end. Capacitors are connected end to end. Here in series connection, charge same on each capacitor. In the series connection. Okay, right? Total voltage V is the sum of the individual voltages across each capacitor. Okay, sum of the, for example, V1 is the voltage in the first capacitor and V2 is the voltage in the second capacitor. So we have to add these two voltages, then we will get the total voltages in the series connection. So total voltage is the sum of the individual voltages across each capacitor. To find the equivalent or total, so equivalent capacitance. To find the equivalent capacitance, that means CEQ. We use the reciprocal formula. For example, so if we connect the 3 or 4 capacitor in a series connection, then the equivalent 1 by, okay, 1 by C equivalent equal to 1 by C1 plus 1 by C2, like that, 1 by C3, like that, okay. This is a equivalent capacitance. Think of it like this, connecting capacitors in series effectively increases the distance between the plates, okay, which decreases the overall capacitance. Connecting capacitors in series effectively increases the distance between the plates, which decreases the overall capacitance. Okay, right. Now we will see the animation for the series connection. I will share the screen. Okay, right. So here you can see the one battery and two plates, which is separated by the some distance. So this is one capacitor. So capacitor has here two plates, upper plate, bottom plate, like that. Okay, right. We can add another one capacitor in series connection with the first one. Okay, so we can choose the two in series. This is a series connection, end to end connection. Here we can click that total capacitance, stored energy, stored charge, voltmeter, okay, like that. And this is a electric field lines between the plates. Okay. In first capacitor, the value of capacitance C1 is 1 farad. Here you can see that 1 into 10 power minus 13 farad. So 1 into 10 power minus 13 farad. And here also C2, 1 into 10 power minus 13 farad. Okay, right. The equivalent capacitance, that means total capacitance. Already I told you that 1 by C equivalent equal to 1 by C1 plus 1 by C2, like that. So here 1 by C1 means 1 by 1. 1 by C2 means 1 by 1. So total 1 by 1 plus 1 by 1, we will get 2. That is 1 by C equivalent is equal to 2. Correct? So then we can take the reciprocal C total, that is C equivalent 0.5 farad. That's why you can see that the value total capacitance. So this capacitance C equivalent, correct? 1 by C equivalent, already I told that 1 by C1 plus 1 by C2, like that. Okay. So now look at that some of the values. I will write on the board and we will verify that. Okay. All right. So C 0.50 10 power minus 13 farad. And then voltage. We can check the voltage by using this voltmeter. Okay. So for example, we can choose the 1.5. Battery voltage 1.5 volt. Okay. Right. Right. So now that 1.5 volt is the battery voltage. But here you can see that 0.75 volt is the voltage on the first capacitor. As well as in the second capacitor also, the voltage value is same, 0.75. Clear? That means the voltage split. Because 1.5 divided by 2, we will get 0.75 volt. Now, just note that stored energy here. 0.56 into 10 power minus 13 joule. So energy means E is equal to 1 by CV square. 1 by 2 CV square. I will write on the board. So 1 by 2 C total means C total 0.5 farad and V 1.5. So we will get 0.5625 joule. Okay, this is all for series connection. Clear? Okay. So first of all, look at that value, total capacitance, stored energy, stored charge, and voltage values. Okay, right. For series connection, C1 1 into 10 power minus 13 farads. C2 1 into 10 power. We can change the value. For example, 2 or 3 like that. Okay. For simplicity, I will take the 1. Okay, right. So V 1.5 volt. V is equal to 1.5 volt. So total capacitance in a series connection means C total or equivalent equal to 1 by C1 plus 1 by C2. Here we can substitute the value 1 by 1, 1 by 1. So 1 by 1 plus 1 by 1, 1, 1, 2. Clear? For the C total, we have to take the reciprocal 1 by C total. Okay, we have to take the reciprocal, then we will get the C total. So 1 by 2. 1 by 2 means 0.5 farad. That's why you saw that C total 0.5 farad. Clear? And voltage. Already I told that the voltage split up. Yeah, voltage split up. That is V is equal to V1 plus V2. V is equal to V1 plus V2. So here the battery voltage 1.5. It split into 2 here. Like for example 0.75 plus 0.75. That's why you saw that in the voltmeter 0.75 volt. The voltage split. Okay. Now we will move into the energy stored. Energy stored. Okay. So energy stored means already I told that capacitor is a device that is used which is used for the uh, storing the energy or charge. Okay. A capacitor store energy in its electric field. The amount of energy stored can be calculated using uh, any one of three formulas. For example, we have a 1 by 2 CV square or E is equal to 1 by 2 QV or E is equal to 1 by 2 Q square by C. The unit for energy is joule. Okay. Right. Clear? So in series connection, so 1 by 2 C total V square. In series connection, the value of C total is 0.5 farad. Yeah. We can neglect 10 power minus 13 plus 13 like that for simplicity. Okay. Right. Into V square. So V means 1.5. So 1.5 square. So we will get the 0.5625 joule. So voltage is 1.5, V1 is 0.75, V2 is 0.75. This is energy and C total 0.5 farad. Right? Now you can see that values. Total capacitance 0.56. 0.50 into 10 power minus 13 farad. Stored energy, already I told you, that is 0.5625 joule. And here also the voltage value. Like this, you can find the stored charge, this value. Okay. So Q is equal to CV. Q is equal to CV. So here you can substitute the T total value, C total value. Okay, right, sir. For example, here Q is equal to CV. Yeah. So C means 0.5, 0.5, and V means 1.5. So 0.5 into 1.5, we will get the 0.75. That's why here stored energy is 0.75 into 10 power minus 13 coulomb. Okay, right? Charge. So coulomb is a unit for charge. Clear? So these are all for series connection. Now we will move into the parallel connection. We will move into the parallel connection. So in a parallel connections, capacitor connected across same 2 points. Connected across same 2 points. Voltage same across each capacitor. Voltage V is same, the V is the same across each capacitor. Total charge Q total is the sum of the individual charge. Sum of the individual charges. To find the equivalent capacitance. To find the equivalent capacitance, that means total capacitance, we simply add the capacitance together. C1, C2, C3, etc. like that. Yeah. So this is for parallel combination. Capacitors are connected across the same 2 points. Voltage is the same across each capacitor. So voltage does not split. Okay. So which is same across each capacitor. Total charge is the sum of the individual charges. And to find the equivalent capacitance, C equivalent equal to C1 plus C2 plus C3, etc. So connecting capacitor in parallel is similar to increasing the plate area, which increases the overall capacitance. Now I will share the screen again for the demonstration of parallel combination. Okay, right. Now we can choose the two in parallel like that. Clear? Two in parallel. Two capacitors are connected in parallel. Okay. So here capacitance 1 farad, battery 1.5 volt. Okay. Now we can check the voltage across each capacitors. So for parallel connection, we should be same for each capacitor. So 1.5 is there. Yeah. Now you can see the 1.5. Here also you will see the 1.5. So be same. Yeah, voltage same across each capacitor. In series connection, voltage will vary. That is voltage split up. Okay. But here in a parallel connection, voltage does not change. It remains same. Okay. Right. Now, just look at that value. Total capacitance. So for total capacitance, we have to simply add the individual capacitance. So here 1 and 1. So 1 plus 1, 2. 2 into 10 power minus 13 farad. So this is the total capacitance. Yeah. Okay. Right. And then stored energy. So stored energy means Q. So Q1, Q2 here. For example, in a single plate, for a single plate, you can see that the stored energy is 1.50 into 10 power minus 13 coulomb. Clear? Because of V 1.5 and total capacitance 2. Okay. Total capacitance 1 into 1.5, 1.5. So Q is equal to CV. So here C1, V here 1.5 volt already. So that 1.5. So we will get Q is equal to 1.5 into 10 power minus 13 coulomb. Okay. But for the two in parallel, just note down the stored charge. Now I will add the another one capacitor in a parallel connection. Just look at that stored charge. Yes. Here 3. Yeah. Because 1.5 plus 1.5. Q1 plus Q2. Already I told that. Q total charge is the sum of the individual charges. So 1.5 plus 1.5, we will get the 3. That's why stored charge is 3. Clear? And then final stored energy. Already I told that energy formula is 1 by 2 CV square. Clear? So here stored energy 2.25 into 10 power minus 13 joule. We will check that. We will check that. That is E is equal to half CV square. So C total, okay, total V square. In parallel connection, C total means 2, 1 plus 1, correct? And V 1.5, which is same for across each capacitor square. Then we will get the 2.25 joule. This is the energy, correct? So you can see that in the stored energy 2.25 into 10 power minus 13 joule. Clear? This is for parallel connection. So for the voltage 1.5, you can see that stored charge, total capacity, and stored energy. Suppose if you if you have any doubt, that for example, why sir we can take voltage is minus 1.5 volt. So voltage minus 1.5 volt means just reversing the plate directions. That means electric field directions. So you can check that like that. Okay. But stored energy remains same. Total capacitance remains same. Stored energy, stored charge remains same. But it denotes just a direction of the electric field lines from positive to negative, like that. Okay. Right. Right. Okay. Clear? These are all for parallel connection. Let's solve a couple of problems on a whiteboard to apply what we learned. Okay. First question, problem number 1. Three capacitors. Three capacitors with capacitance of 2 microfarad, 3 microfarad, 6 microfarad are connected in series. Connected in series. Find the equivalent capacitance. Very, very easy formula, easy sum. Find the equivalent capacitance. Yeah. Okay. So we use the formula, reciprocal formula, that is 1 by C equivalent equal to 1 by C1, 1 by C2, 1 by C3. Like that. 1 by 2 microfarad, 1 by 3 microfarad, 1 by 6 microfarad. Like that. So to add these fractions, we find the common denominator, which is 6. Yeah, which is 6. So 3 by 6 microfarad, 2 by 6 microfarad, 1 by 6 microfarad. Okay. To add these fractions, we find a common denominator, which is 6. That's why I am putting like this. Already you know that 1 by C equivalent equal to 3 plus 2 plus 1 whole divided by 6 microfarads. Clear? Okay. So 3 plus 2 plus 1 means 6. So 6 by 6 microfarads. We will get the 1 microfarad. We will get 1 microfarad. Clear? So this is 1 by C equivalent. For C equivalent, we have to take the reciprocal. So that's also 1. So 1 microfarad. The equivalent capacitance is 1 microfarad for this problem number 1. Clear? Note it down. I will move into that next sum. Problem number 2. Okay, right. Problem number 2. A 5 microfarad capacitor, a 5 microfarad capacitor is charged to 10 volt. Calculate the energy stored. Calculate the energy stored. Okay. So we use the formula E is equal to half CV square because we have a C and V. Suppose if we have the for example charge voltage or charge capacitance, we can change the formula. Okay, so for this case we have a capacitance and voltage, so that's why I am putting this formula. E is equal to 1 by 2 CV square. Okay, 1 by 2 C 5 microfarad and V square 10. Yeah, so 10 volt to the square. First of all, we will convert microfarad into farad. So micro means 10 power minus 6. Yeah. So 1 by 2 into 5 into 10 power minus 6 farad. 100 because 10 into 10, 100. 100 V square. Clear? Okay. 1 by 2, 5 into 100, 500 into 10 power minus 6. Clear? And we will put the unit joule here. So 1 by 2, 500 into 10 power minus 6 joule. 1 by 2 into 500, 250. 250 into 10 power minus 6 joule, and then 250 microjoule, because already I told you micro means 10 power minus 6. So here also we will see that 250 into 10 power minus 6 joule. So we can put that microjoule. So the energy stored in the capacitor is 250 microjoule. The energy stored in the capacitor is 250 microjoule. Please note it down. Please note it down. Yes, 250 correct. Yes. Yes, very good. Yes, good. Okay. Right. So now it's time for a quick 5-question quiz to check your understanding of today's topic. I will share the screen now. You can find that. Okay. This is a 5 question. 5 quiz. Okay, right. First question, for a capacitors in parallel, the equivalent capacitance is, which one is correct? Sum of the reciprocal, product over sum of the individual capacitance, average of capacitance. Already I told you, in a parallel connection, capacitors are connected in the same point across each point. Already told that. So the equivalent capacitance is, yes, very good. Xiaomi, IFP, AP, RJC, IFP, yes. Fluoroid TV, good. Yes. C, very good. Sum of the individual capacitance. 1 farad plus 1 farad, which is connected across the parallel connection, we will get the 2 farad, like that. Yes, very important one. Right. Then next one, the energy stored in a capacitor is proportional to, energy stored in the capacitor is proportional to voltage, square of the voltage, inverse of the voltage, or square root of the voltage. Which one is correct? B, square root or square? Please look at that. Square roots. Square. Yeah. B. Very good. A. Which one is correct? The energy in a capacitor, it's proportional to the, yes, square of the voltage. Already I told that. Yes. E is equal to 1 by 2 CV square. So E is directly proportional to V square, square of the voltage. Yeah, very good. Correct. Now we will move into the third one. 4 microfarad capacitors in series have equivalent capacitance of, which one is correct? 4 microfarad capacitor in series. So just to find that, which one is correct? Eight microfarad or 4? Which one is correct? Okay. CA, 2 microfarad. Okay. D, 1 microfarad. Oh, lot of answers. Yeah, which one is correct? You can add that value. For example, 1 by C equivalent is equal to 1 by 4 plus 1 by 4. Correct? So 1 by 4 plus 1 by 4, we will get the 2 by 4. So 1 by 2. So in the final, we have to take the reciprocal. Yes. So then only we will get the 2 microfarad. Correct? Yes. Option C is the correct answer. Very good. Clear. Okay. Fourth one. If a capacitor stores 100 joule at a 20 volt, its capacitance is, think about it. If a capacitor stored 100 joule at 20 volt, and what is its capacitance? C. Its capacitance C. Already I gave you a formula. E is equal to 1 by 2 1 by 2 CV square. Yeah. So C equal to 2 into E by V square. E 100 joule. So 2 into 100 joule by V square 20 volt to the whole square. So 20 volt to the whole square means 400 V square. So 2 into 100 joule, 200 joule. So 200 joule by 400 V square. The capacitance is is yes, option A. Yes, correct. Very good. Option A is correct. 0.5. Yes, 0.5 farad. Yes. Okay. 0.5. We have a energy and we have a voltage. So capacitance 2E by V square. We will get the 0.5 farad. Yes. Yes, correct. What do you mean by charge? It's capacitance. C. Okay. And that final one, in a series combination, which quantity is the same for all capacitors? Very important one. In series combination, which quantity is the same for all capacitors? Voltage, charge, capacitance, energy. Which one is correct? A, B, okay. Which quantity is same? Already I told that. Yeah. Charge. Okay. Oh, for charge for this problem. Okay, okay, okay. A, B, 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 A, D. Okay. Yes. So charge is same for all capacitor in a series combination. In parallel combination, voltage is same for all capacitor on all each capacitor. Okay. In series connection, charge same for all capacitor. Okay. Option B is the correct answer. Very good. Clear? Okay. Let me check the answer. For capacitor in parallel, the equivalent capacitance is the sum of the individual capacitance. The energy stored in the capacitor is proportional to the square of the voltage, 1 by 2 CV square, 2 4 microfarad, which gives 2 microfarad, which is the equivalent capacitance. If a capacitor stored 100 joule at 20 volt, we will get the 0.5 farad is the capacitance. In series combination, which quantity is the same for all capacitors? Charge. Okay. Very good. Clear. Very good. Super. Correct? Okay. Right. So now it's a time for you. What questions do you have? You can ask about any about the capacitor combination, energy calculations, or anything you observed in the simulation. For example, some great question to think about that is how does adding a um, dielectric material between the plates affect energy storage? So here in the simulation, the medium is vacuum. Yeah. Suppose we can add that or we can insert a dielectric material between the plates. So suppose if we add the dielectric material between the plates, energy question mark. Okay. And you can think about another other questions also, like that. What is the equivalent capacitance in a series connection or parallel connection? Which one is great? Which one is less? Like that. Clear? Okay. So today we learned about the two primary ways to combine capacitors, series and parallel. Yeah. In series connection, charge same. voltage sum. So add up. Okay, right. Add up. Okay. And we can use a reciprocal formula. For example, for the two capacitor, 1 by C1, 1 by C2, C equivalent means we will get the reciprocal answer. Okay, right. For parallel connection, voltage is same. Already I told that voltage is same. Charges add up. And we use the direct formula, direct sum. For example, C equivalent is C1 plus C2. Like that. Clear? Okay. So, and the final energy is equal to 1 by 2 CV square. We can also use the U symbol in the place of E. U or E. Clear? Okay. So, your homework for today is to solve the following two problems, which will help you practice these concepts. Okay. I will write the homework problem now. Homework. First problem. 4 capacitors of 1 microfarad each are connected. 2 in series. Then those two sets are connected in parallel. Find the total equivalent capacitance and show all your steps. And show all your steps. Second problem. A 10 microfarad capacitor is charged with a 12 volt. Okay, I will write the 12 volt battery. Calculate energy stored. Calculate energy stored. And explain what happens to the energy if the voltage is doubled. Okay. So a 100 microfarad capacitor is charged with a 12 volt battery. Calculate the energy stored and explain what happens to the energy if the voltage is doubled. If the voltage is doubled. Clear? These are all for today. Clear? Note it down. Okay. Please note it down.